And we're back, guys. Hello. We're going to be looking at 5.2, relations and functions. As you can see, the background is a little different because I'm not in the conference room anymore. I'm in the actual math room with the geometry class. Geometry class says hi. See, I'm not kidding. Alright, so let's go ahead to the first slide, guys, other than the title slide. These are definitions that you're going to need to know. This whole little slide is going to be needed to be written down in your interactive notebook. You've got the definitions for relation, domain, range, function, function rule, and function notation. Ryan, I'm speaking on a recording. Falconberry, the funny thing is that the Ryan in the geometry class sits in the same spot you do in Algebra 1. Very weird. Anyway, and he's just as loud. Alright, relation is a set of ordered pairs. Domain is the set of input values, the x values or x coordinates. Range is the set of output values or y values or y coordinates. I said coordinates wrong or weird. So like I'm from some other place, talking weird. Anyway, function is a relation that assigns exactly one value in the range, which is y, to each value in the domain, which is your x. Remember y value, y coordinate, x value, x coordinate, blah blah blah. Function rule, an equation that describes a function. And in function notation, when you use fx, or f parenthesis x closed parenthesis, to indicate the outputs, and you read that f and the x with the parentheses as f of x. Go ahead and pause your little video thing right there so you can write those notes down. Go. Alright, that's enough for my pausing little thing. We're going to go ahead to the next page. So I'm not going to sit here and like this for like 15 minutes while you write. Alright, page 3. I'm talking to them. I'm really talking to them, Kira. They don't believe it, but I'm talking to you. I love you. Alright, here are 3 points to remember, guys. You're going to want to write these down, too. I'm getting laughed at just like when I'm in class with you. Alright. Point number 1, you can use the vertical line test or a mapping diagram to determine whether a relation is a function. Point number 2, vertical line test. Hold that thought. Yes, I'm recording myself teaching them, and they'll watch this video later. That's Kira. She's nosy with her mustache. Alright. I am. Alright, so vertical line test again, guys. I'm sorry about that. If any vertical line passes through more than one point on the graph, the relation is not a function. And then mapping diagram. The domains, x values, or coordinates must all be different numbers, but the ranges can be the same number. And before we go on, let's go back to slide 2. Remember your range. Well, I didn't click my pen button. Alright, the range right here is your y. Domain is your x. Now, can anybody think of how you can remember that? Well, come over here and tell us, Kira. How can you remember the difference between domain and range? Come talk to the camera. It's right here. I'm blocking you. Okay, well, she's going to tell me and I'm going to tell you. X comes before Y. Very good. D comes before R. Domain X. Range Y. Very awesome thing. Alright, so back to our little thing. We're actually going to go to slide 4. Thanks, Kira. I said thank you. Alright, so here's our example 1 using a mapping diagram. It says determine whether each relation is a function. And we're given the points 11, negative 2, 12, negative 1, 13, negative 2, and 27. We've got our domains. Let me get a little highlighter button going. We've got our domains right here, which it's our x numbers. See where I just highlighted? That's x. X is on the left, y is on the right, because x comes before y in the alphabet. Just like D for domain and R for range. D comes before R in the alphabet. I'm going to switch my little highlighter color to green. And here's our range numbers right here. Our range is on the right. Whoever's choking can get some water. I'm distracting my freshmen. Alright. gotten our domain numbers in one box and our range numbers in the other box, what you can see, you've got 11, 12, 13, 20, just like you had at the top, and 2, -1, and 7. Now we said that you could have, let me change colors again, they said you could have more than one point going in the same direction in the range, but you can't have the domain numbers repeated. So our domain numbers are all different, but we have a repeated range number. But this is a function. Look over here on this other side. You've got -2, -1, and 6. -2 is used twice, and that's in your domain. Because we have -2 used twice in the domain section, this is not a function. Hold on one second, freshmen. Y'all are really loud from my recording.
I'm not being loud.
Shh, you are. I need it dead silent in here. A little, yeah, you want to go to the bathroom and fix that. Kira lost her mustache, guys.
Missy that, guys.
Alright, so we're going on to the next slide. Alright, use a mapping diagram to determine whether each relation is a function. Now on this page before, we saw what the mapping diagram was. So we're going on to number 5. Hold on. After she comes back, one at a time. They can't go to the bathroom by themselves, guys. Alright, so let's go ahead and write this stuff down. Now remember, domain is the first number that you see. So we have 3, 8, 9, 3, -4. 3, 8, 9, 3 again, and -4. Now, we already just started with our domain, and we see that we have to use 3 twice. So is this going to be a function? No. I just repeated a domain. I only have to finish putting the range in there to know what, oops. I don't have to put the range in there to know whether it's going to be a function or not. I just have to look at the domain. Alright. Over here we have 6.5, 7, 6, 2, and 5. Did I repeat anything? No. All those domain numbers are separate from each other. They're not sharing a range. So this one will be a function. And that's a really sorry check mark. Sorry, guys. And let's go to the next page. Alright, using a vertical line test. Determine whether the relation of 3, 0, -2, 1, and 0, -1, -3, 2, and 3, 2 is a function. So the first step we have is to graph the ordered pairs on a coordinate plane. As you can see, we have -3, 2. Over here is -2, 1. Right here is 0, 1, -1. We have 3, 0. And then we have 3, 2. Now, pass the pencil across the graph as shown. So we have pencils on the graph. They kind of rolled it up there on each line to see if we have anything being used again in the domain. And what do we have being used twice? That 3.
That's Missy and the stash. Okay.
That's good, Kira. Our 3's are repeated. See right here? 3, 0, and 3, 2. So this is not a function. Alright. So we're going to go to our own little graphs, and we're going to put this together and see if these are graphs or not. Make my line a little bit thicker for this. Alright, so we're going to do 4, -2. So 1, 2, 3, 4, -1, -2. Because remember, your x goes this way or this way, and your y goes this way or this way. So we've put that one on the graph. 1, 2, that's been graphed. 0, 1, that's been graphed. And -2, +2, that's been graphed. Now I don't exactly have a pencil that I can put on the screen to show you whether this goes in a line or not. But what I can do is just come back with the highlighter and highlight in yellow each one. So I go down, 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 down. Are any of my points on the same yellow line? Absolutely not. So this right here is a function, guys. Now let's go back to the pen. I'll use red this time, because I can. Alright, so we're doing 0 and 2. 1, 2. Because our 0 didn't go anywhere. Alright, 1, negative 1 goes right there. Negative 1 and 4 goes right there. 0, negative 3, right there, sort of. And 2, 1. Ah! I can't get my thing to right. 2, 1. As you can see, I left out my 0, negative 3. That's why I was putting check marks on all of them on the left side. Because if I don't, I forget one, just like I did right then. So now I'm going back to the highlight as the geometry class gets louder and louder. And I'm going to check my lines here. That doesn't have a repeat, that doesn't have a repeat, that doesn't, but this one does. As you can see, 0 is used twice in the domains. So this one here is not a function. Moving on. Evaluating function rules. It says evaluate f of n equals negative 3n minus 10 for n equaling 6. This is worked out just like the regular problems we've been doing all this time in algebra and before that, when you were in 8th grade. Not sure about 7th grade, but we've been doing all this for a while, guys. So you see where I'm saying n is 6? All I'm going to do is put that 6 in the place of n. So that's why this 6 is here, and this 6 is here. So I just say negative 3 multiplied by 6 becomes my 18, and then I bring down my negative 10. So negative 18 minus 10 is negative 28. So f of 6 is negative 28. Over here, I have y. Now remember, f of n, y, g of x. Hold on, you have 2 minutes left. All of these here are your output. These are your output, just like y, f of n, g of x. They're all going to look for the same thing. So here I'm saying, put negative 4 in for x. So I'm going to put that negative 4 in for x, and I get negative 2 multiplied by negative 4 squared plus 7. You're going to do this right here, the square first, which gives you a positive 16 multiplied by negative 2, giving you that negative 32. Bring down your 7 each time. Negative 32 plus 7 is negative 25. So let's do this one over here together. We have g of x. I'm still using the highlighter pen for some reason, but we're going to just roll with it, guys. Negative x plus 2. And we're saying negative 3 goes in for the x. So g negative 3 equals a positive 3, because we see you have a negative here, but our x is negative, so it becomes positive 3 plus 2. So g of negative 3 equals 3 plus 2 is 5. Don't laugh at my jacked up equal sign, guys. Alright. Ma'am?
Why am I on your keychain?
Because you can be. Alright, I had another slide by accident, guys. We are on the last bit here. As you can see, it says find the range of each. Oops. It's still 1:44, guys. That's the wrong clock. I'm going by my computer clock. You may now go. Geometry says bye. See? Alright, so find the range of each function for the given domain. Let's look right here. I've got a negative 2, a 0, and a 5. All I'm going to do is plug in each one of these numbers in for x over here, for f of x. I'm going to plug them in for x in this y question, and then I'm going to plug them in also for t. See, my t. Alright. Over on this side, I put f of negative 2, because our first one was negative 2, equals negative 2 minus 6. Negative 2 minus 6 equals negative 8. Then I go back with the same equation right here, and I plug in 0 for my x. So 0 minus 6 is what I end up with, equals negative 6. So negative 6 is your answer. Lastly, I plug in 5 for that same problem. This is 5 minus 6, which gives me a negative 1. So that's your answer for that third one. And I wrote the answers down here. So negative 8, negative 6, and negative 1. Over here in y equals a negative 4x, we're going to plug in these same numbers again. So y equals negative 4 minus, or multiplied by negative 2, which gives me 8. Because a negative multiplied by negative gives me a positive. I have y equals negative 4 multiplied by 0, which we know equals 0. Anything multiplied by 0 gets what? 0. Lastly, I have y equals negative 4 multiplied by 5. Since this is a negative here and this is a positive, your answer is going to stay negative, so negative 20 is your answer. And I can see here when I was writing this stuff down, I was not even thinking. I wrote down the numbers from the top, guys, so let's mark those out. The answers are actually 8, 0, and negative 20. See? Parker is going to sit there and look at that and go, "You made a mistake again!" I know, Parker. I know. Alright, so let's do the g of t together. So, let me make that thinner. G of t equals t squared plus 1. I'm writing it again because I have that really thick g and I don't want to write with it. Okay, so g of negative 2 equals negative 2 squared plus 1. So we're doing negative 2 first. So g of negative 2 equals negative 2 squared is going to be a positive, so that becomes 4 plus 1. So, oops. So you're going to have g of negative 2 equals 5, because 4 plus 1 is 5. Switching colors. Alright, so we're going to do this again with g, and t will now be 0, equals 0 squared, which we know will be 0, plus 1. So g of 0 equals 1. And lastly, let's see, I'm going to go with a dark green this time, because I feel like dark green. I haven't had that on any of my slides yet. We're going to say g of 5 equals, let's see, 5 squared, I promise that's just 5, guys, plus 1. So g of 5 is, and 5 times itself is 25, so 5 squared is 25, plus 1, so g of 5 equals 26. I'm going to write the answer up here since I took up all that space down there. So my answer for this problem, my answers are 5, 1, and 26. I hope this has been helpful. Go ahead and finish taking the notes on this slide and the other slides. You can rewind, pause, whatever you want to do, and I will see you later. Bye, guys.